Hi guys, welcome to More Wavy Motions lab. This is what I consider a big boy lab. There will be a lab quiz at the end. This lab is a little bit different because you get to choose your IV, and I'm going to recommend a DV for you. Alright, so I'm going to walk you through this lab. So, the main thing you have to do and the hardest thing you have to do is brainstorming. And you just finished Wavy Motions. I know all the titles sound the same for this power standard, but Wavy Motions it was a worksheet and you had to follow the directions with a slinky, and you made 3 types of waves. The first wave, you took a slinky and you spread it apart, and one person pulled it to side and it made a transverse wave. And then the other one, it says shake it side to side, like 1.5 or half a meter, and then you made a transverse wave. The other one said take some compressions, pull them back and release, and that made a longitudinal wave. So now you're going to create your own investigation involving waves where you get to choose the IV and DV. So the purpose is basically to design an experiment. And we're going to show you a good way to brainstorm. And the first thing it is, we need to determine a DV for your experiment. So like, how do you think, what are something that we can measure about our waves? So I'm going to talk about this, things that we could measure for our waves. Ooh, that noise still made it. I'm going to try to mute it so it doesn't make that noise from my airliner. Alright, so things we can measure for the waves. We can measure like amplitude, right? We can actually measure that. We could measure wavelength. But if you think about the waves we make, it's really hard to measure the tallness, which is amplitude of a wave, if the wave is moving. And likewise, how do you measure how wide the wave is, the wavelength, if the wave is, again, moving? We need to measure something that doesn't require us to like stick a ruler on top of it, like amplitude. Remember, amplitude is the tallness, or, dang it, that noise again, or the wavelength here. So we need to think of a way to avoid having to keep the wave still. So what if we measure, let's say, well, you throw the wave down there and it bounces back to your partner. What if, that's called reflection, what if we measure the number of reflections? Well, that's what I want to strongly recommend that you do, is measure the reflections, how many reflections there are in your wave. And that's going to be our DV. We're going to put our DV in the middle of the variable wheel. So we basically did that, and now we need to write possible ways you could change your item. We need possible IVs. So what I need you to do right now is draw this variable wheel, put a circle here, and we'll put a DV in there. We'll put the green one, reflection. And then we're going to draw these spokes here. So I'm going to turn the page, and you'll see what I mean. So here's the variable wheel that I need in your notebook. If you haven't done it yet, please pause the video. So here, we're going to write the DV, number, that pound sign means number, of reflections. So that is our DV. Let's put a sign to it. DV, squeeze in here. This is what we are going to count. So you're going to send the wave down to your partner, and we're going to count how many times it bounces from your partner to you, to your partner to you, to your partner to you. Okay? So that's what we're talking about here. What can we do to a slinky to possibly change that? Well, we could change, the size of a slinky. Right? That's something we could change. What else could we change to a slinky? Oh, we could change the surface the slinky is on, right? We could do that. We could change how far to the side we pull. Remember that first one we said pull to the side? What if you measured that distance, how many pull to the side? Or we could change the number of coils hold back. Remember that one? Where you had to pull them back towards you and you released your hand and they bounced back and forth? We could change that. Oh, we could change how far we shook the slinky, right? We could change that. If I had the right materials, we could change the brand of slinky. Let's see, what else could we change? I don't know. If we could have changed the temperature of a slinky, I guess. But that's going to be kind of hard to come up with. How do you heat up a slinky? You can't put it in a microwave, so that might not be a very good one. So what else could have changed? Think of some more ideas of possible IVs. All these and the outside spokes are your possible IVs, which is why it's called a variable wheel. These are all variables going around the wheel. So basically, I need you to choose a variable. Let's say I want to change the surface I make my waves on. So this is going to be my IV. And you can have your IV be whatever you want. And the cool thing is, this is a constant condition. This becomes a constant condition. This becomes a constant condition. This, and this, and this. And if I filled in these blanks, this, and this. I don't have to do any of that thinking anymore. I came up with all my constant conditions once I selected which circle here is my IV. So highlight the circle you want your IV to be in. I just put a little circle around it. But there should be highlighters out in your area. Highlight the one that's your IV and then write CC next to the rest. Okay, so now you should have, if you didn't grab one already, grab one of these. It is your experimental design diagram. So we're going to try to fill, I'm going to fill some of this out with you. Okay? So there's different ways we can make a wave, and this is something that's probably going to end up becoming your constant condition. I'm going to talk to you about the 3 ways that we talked about we can make a wave. Here are some of them. Remember, you could just shake it back and forth, right? You could do a compression forward and backwards. So this one up here, they are actually sending a compression. See the little compressions going on along? So you could pull it back and forth, or you could shake it side to side, or you can, I like this one the most for some reason. You have a partner here and you're here, and one of your hands is holding it right here, the other hand pulls it to the side. You literally could measure that distance and say, oh, that's 15 centimeters. Next time I'm going to do 20. Next time I'm going to do 25. That would work too. So there's all different ways. Whatever you choose to do, you have to keep it consistent. So let's fill this out. I don't know what your problem statement is, or your independent variable, or your levels of IV. That is something you are coming up with on your own. The control, remember, needs to be either the group, that's your baseline. Do not write that, that's just what it is. So this is, oops, it's not what I meant to do. So this is your baseline, and it is what you're compared to. So it's probably, as a hint, it's probably your lowest level of the IV. If you need help figuring out which one your control is, please ask us. Okay, your dependent variable, I want us all to do the same dependent variable, and it's the number of reflections, right? But really, we're going to call that something fancy because we like to use as scientific terms as possible. So we're going to call that wave duration. The word duration means how long it lasts. And we're going to measure that by counting the number of reflections. So we're literally just going to count how many times it bounces back. And that's how long the duration of the wave is. So again, the duration just means how long. The duration of this class is about 46 minutes. It's just how long it lasts. Constant conditions. We need to start thinking about some constant conditions you need to have. One thing you need to have constant for sure is the type of wave you're making. Transverse and longitudinal waves do behave differently. And then you need to think of about 2, 3, 4, 5, 6 constant conditions minimally. And be specific here. Do not just say waves. What about the waves need to stay the same? Don't say slinky. What about the slinky needs to stay the same? And then you need your hypothesis. If IV increases, then the dB we know is wave duration. If the wave duration will increase, decrease, or stay the same. We probably could fill out wave duration up here too. But I cannot fill out your IV with you because, again, this is your experiment. I don't know what you are going to choose. And there's so many of you, couldn't even tell you. Here's things to keep in mind. You really need to keep the wave production method constant. That's why we put it under constant conditions similar. So if you are shaking back and forth, keep that shaking consistent. If you're pulling to the side, you can't then start shaking back and forth. Be careful with my slinkies. They cost us money. They're not free. They don't grow on trees, and we don't want them tangled up. If you do tangle, don't fix them. I am the master at fixing them. Ask Miss Burkhart. She'll tell you. I have fixed every slinky detangled. But just come to me and let me know. And then graphing. Refer to your cheat sheet in the beginning of your science notebook if you need a graph. Some of you will be doing bar graphs. Some of you will be doing line graphs. It depends on your independent variable. So when you graph, you'll put your IV down here. If that's numbers, it's a line graph. If this is words, like carpet, tile, table, it's a bar graph. Come ask me if you need help. And don't forget, there's a lab quiz at the end. And it will include graphing. Yay, lucky you. Okay, so don't forget, graph your results, write your conclusion. These are the things that every conclusion needs to have in science. It needs to have claim, evidence with numbers, specific numbers. And then state whether or not your hypothesis is supported. And don't forget to show your teacher before you take the lab quiz. If you have any questions regarding this lab, or choosing your IV or executing this lab, please see me. This is your first time getting a lot of freedom with a big boy lab. Okay, we'll talk to you guys later. Bye.